Alpha decay is one of the most important types of radioactive decay in nuclear chemistry. It involves the emission of helium nuclei from unstable atomic nuclei, resulting in the transformation of one element into another. Alpha decay is a type of radioactive decay where an unstable nucleus emits an alpha particle to become more stable. This process occurs naturally in heavy elements that have too many protons and neutrons to maintain stability. An alpha particle is represented by the Greek letter alpha, or as helium-42. This notation tells us that an alpha particle is identical to a helium-4 nucleus, consisting of 2 protons and 2 neutrons bound together. Let's break down the composition of an alpha particle. It contains exactly 2 protons, which are positively charged particles, and 2 neutrons, which are neutral particles with no charge. Together, these 4 nucleons form a very stable particle. The general equation for alpha decay shows that a parent nucleus with mass number A and atomic number Z transforms into a daughter nucleus with mass number A-4 and atomic number Z-2, while emitting a helium-4 particle. During alpha decay, 2 important changes occur. First, the mass number decreases by 4 because the nucleus loses 4 nucleons. Second, the atomic number decreases by 2 because the nucleus loses 2 protons. This change in atomic number means the element transforms into a different element. Let's examine a real example. Uranium-238, with 92 protons, undergoes alpha decay to form thorium-234 with 90 protons, plus an alpha particle. Notice that the mass number decreased from 238 to 234, and the atomic number decreased from 92 to 90. To summarize, alpha particles contain 2 protons and 2 neutrons. During alpha decay, the mass number decreases by 4, the atomic number decreases by 2, and the parent nucleus transforms into a different element. Understanding alpha decay is fundamental to nuclear chemistry and radioactivity.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.